All right. So today we're actually going to get into chapter 12, which is kind of a introduction to calculus. So we're going to look at limits and continuity and what that means. So this is just part A of this. It's time for the beginning of calculus, and Isaac Newton would be very approving of this. So we're going to start off by talking about what a limit is. Now, limits are sometimes seem very confusing, but we'll try to simplify it as best as possible. So suppose I have some function f of x equals 3x plus 2. Now, if x equals 2, then f of 2 is equal to 8. Now, let's say that x doesn't equal 2, but instead it equals something really close to 2, like 1.999 or 2.0001. What is f of x going to be close to? Well, definitely it's going to be close to x. So then f of x is going to be pretty close to 8. Now, that's the basic idea of a limit, is what does the function look like as we get closer and closer and closer to the x value? What does the f of x value look like? Now, so a limit tells us what the y value is close to when an x is close to a particular number. So if I have some input and it's getting closer and closer to a certain number, well, what's the output getting closer and closer to? Now, here's a very convoluted definition that when you get to calculus, you'll describe this a little bit more. But basically what this is saying is that as the input gets closer and closer to some value alpha, well, then the limit of this function gets closer and closer to the value L. Now, where do we begin on a problem such as this? If I have just 2x minus 1, well, we can just plug in the value of 1. As x gets closer to 1, what does 2x minus 1 get closer to? Well, it's pretty simple. It gets closer and closer to 1. So our final answer to this problem is just simply 1. So if the function is defined at that point, well, then that is the value of the limit as well. It gets tricky when the function is not defined at that point, is what we're going to look at in our next ones here. So to summarize this point, the steps to take when finding a limit: try plugging in the number. If you get a real number, then that's your answer. Now, we don't have a step 2 yet. That's where we're going to go next. So what happens if f of x is undefined? Okay, that's a little complicated. Suppose you had this problem. Limit as x approaches negative 2 of x plus 2 over x squared minus 4. If you plug in x equals negative 2 into this equation, you will get 0 over 0. Now, make sure that you don't make the mistake. You can, at no point can you ever have a 0 in a denominator and claim that it's a real number, okay? 0 over 0 does not equal 1. 0 over 0 does not equal 0. It's not even a number, okay? The official word for this situation is undefined. Now, even if it's undefined, we can still find the limit. Let's look at this graph as a graph of this function. If we were going to do it on our calculator, the function would look something like this. Now, notice that as x gets nearer and nearer to negative 2, the y value is awfully close to negative 1/4. So how can we find this on our own? Well, if we went back to the original equation and tried factoring the numerator and denominator, well, we can factor the denominator into an x squared minus 4 into x minus 2, x plus 2. The x plus 2's would cancel out, and we would have 1 over x minus 2 is equal to negative 1/4 as x approaches negative 2. Now, that's what we looked at when we got the graph here. So when we have 0 over 0, we can probably factor something and get a pretty good idea of what the limit is going to be. So If we plug in the number and get a real number, that's our answer. If we get 0 over 0, try to factor the original equation, simplify and plug in again. And then now if you get a real answer, that is the answer to the limit, okay? It's not an answer to the function, but it's an answer to what is the limit of that function. Okay, we haven't gotten to step 3 yet. We'll take a look at that now. So here's an example. If I have x plus 1 over x, I get 1 over 0. Okay, that's not a fun result here. Let's remind ourselves, okay, we can't have a 0 in the denominator. 1 over 0 does not equal 0. It's not equal to 1. It's undefined. So these limits fall under what are called right and left-hand limits. Now, what to do on these problems? Try plugging in the number. You get the real number. That's your answer. You get 0 over 0. Factor the original equation. Simplify and plug in again. If you get a real number this time, that's your answer. And if you get a number over 0, we'll look at that next time. Right now, we're going to simply write down that we don't know the answer yet, but we'll be able to do these rather quickly. So we're going to take a look at the in-class worksheet in just a second here.